the class. Be careful with that. And this is the first one, is the scatter plot. That's the first symbol. And the x list is my list L1 has the x variable, yes, and so on and so forth. And let's say I want to use the squares. I want to use blue, okay. And I have to be careful now because I have to go to the viewing window. All my my data set is between 20 and 45. So I will say from 20, because otherwise you will not see anything, to 45 with a scale of 4, let's say. Y minimum, same thing, 20 to 45 with a scale of 4, and then I click graph. Here it is. Oh, somehow that was, I can adjust that and go to 50 here so I can see it better. It was on the y-axis actually. Okay, so this is the scatter diagram. And in order to determine what we are going to try to find in the next section, we're going to go to stats and calculations. And we want the linear regression, which is number 4. I'm going to choose 4. And yes, everything is okay. Yes, I also want to see that linear regression stored in y equals. Yes, I'm going to press enter and calculate. So, sorry. So I want this to be stored in second, no, not second, sorry, variables. Yep, I want variables. Nope, I didn't mean that. I want variables in y1, function y1. Okay, and then calculate and press enter. So it will give us the correlation coefficient. It's not a true one because I only used 5 entries. Now, if you do not see this, you have to go to diagnostic and turn it on. So let me think for a second how I get to diagnostic. Second and catalog. You can click on D directly or just scroll down to right here. Make sure you click on diagnostic on. So you can see the R and the R squared. So second catalog, and go to diagnostic and click on. And you only have to do that once. So back to where I was, calculations, number 4. And you already saved it, I'm sure. I don't have to do that again. Oh, in order to, let me show again how to save it as a function. So you go to variables, go to y variables, and click on function, and choose the function you want to use. I'm going to use a y1, and you will store it, and now calculate. Why will store it? Because I don't want to punch in all this. You will see what we do with this. So the correlation coefficient is negative 0.66, which is moderate to high negative correlation between the two variables. So A is the slope of this line, this number, and B is the y-intercept of this line, 75.56. Okay, is this okay?
What's the R squared?
It's the square of R. It's called the determination coefficient.
Okay.
And this coefficient will be between 0 and 1. This coefficient is always between negative 1 and 1.
Thank you.
Thank you. We're going to talk about that too. Okay, where am I now? I'm here. Okay.
Professor?
Yes?
For the test, are we allowed to, we can use Statcrunch,
Yes.
right?
Yes.
Okay, just making sure.
Yes. Okay, what am I trying to do here? I'm trying to, okay, to do the scatter plot, yes. So the X variable, female, the Y variable, male. Okay, and compute. So here is the scatter diagram. Now, see, the Statcrunch gives us the correct viewing window, but the calculator does not. So you have to be very careful. Otherwise you will not see the scatter plot if those points are not in your viewing window. So that's what I did first. I selected the correct window for the data set I had. So between roughly, I put 20 and 45. Of course, here we have other entries, so that's why it's higher. But I put for the first 5 between 20 and 45 or 50, so I can see all the points.
I have a question.
Yes.
Would that graph be unrelated because the dots are all spread out everywhere?
It looks like that. It looks like that. So, as I said, one was what the observations, the 5 points that we used, could have given us other interpretation, but it looks like it's all over the place. I don't see any correlation between the two. Okay, so back to, where am I? I think I'm here. So it doesn't look like this. It doesn't look like this. Now,
I think it was A, because you had the one dot at the very top around the middle.
okay, I trust you. Good. Now, briefly characterize. It's not positive. It's not negative. I don't think it's weak negative.
It's just no correlation.
I think it's no correlation. In my opinion, this is no correlation. But they don't see, they never cease to amaze me sometimes. So, okay. Estimate the correlation coefficient or calculate blah, blah, blah. Okay. So back to, where was I? Here. And we want to stats, summary. We want correlation. And we have to choose both, always. It's a correlation between 2 variables. And let's see what we get. I got negative 0.1123. So let's see how many decimals they want. Negative 0.112353. I don't know. Let's see. Where am I? Here. Okay. Type an integer or a decimal rounded to 1 decimal place. So I have minus 0.1. It says 1 decimal place. Am I correct?
Yeah, just 0.1.
Okay. Negative, don't forget negative. Negative 0.1. Good. Anything else from here, or we continue with 4.2?
Can we do that last part of the question?
Oh, yeah, I didn't see it. Is there something else? Oh, yes, it is. Okay, comment on the relationship between the 2 variables. While the value of R is close to 0, the distinct pattern in the scatter plot implies that the ages in the male and females born in a given year are strongly, no. The distinct pattern in the scatter plot and the value of R both indicate that the ages of award years in a given year are strongly no. The points are loosely scattered and the value of R is close to 0. So it seems safe to say that the ages of the male and female award winners in a given year are unrelated. Do not click on anything before you read the last one. Okay, we know the English language has a lot of interpretations. While the points appear to be loosely scattered, the value of R implies that the ages of the male and female award winners in a given year are strongly, okay, got it. Good. Anything else from anything?
I think we can move on.
Yes?
Yeah, we're good.
Okay, perfect. Moving on then. Where am I? I'm here. Good. So finally, in 4.2, we are talking about what I already mentioned, the least squares regression line. 4.2, the least squares regression line. Okay. We already found it for one, or we'll go back and find it again for, because we didn't find it with the Statcrunch. We did find it with just for these 5 observations, ordered pairs. Okay, what does this mean? Okay. So again, I just have a scatter plot. I will say that this is, it shows a linear positive correlation between X and Y. And the idea is here, I would like to be able to predict. So I want to predict values for the Y variable, for Y, for X that I don't have, for X values that I'm interested in but I don't have, that I do not have. So the question is, how can I do this? Well, we will find what is called the least squares regression line, which is a line. I'm going to draw a few of them. So I'm going to draw one line in orange, one line in purple or red, and the other one in green. No line can pass through all the points. It's not possible. Now the question is, from the orange, red, and green, which of these 3 lines you think has the least error? What is the error? Okay, the error is the distance between each point and the line. That's the error.
So the green would have the least error?
Yes, that's why this is the best fit, because it has the smallest error. They all have error, but it's the smallest error. What would I want to do with this? So once I find this, which will have, I'm going to write it again, it's Y hat. So as you see, it's possible that it will pass through 1 or 2 points, right? But very unlikely that it will hit too many. So that's why this is hat, because it's called predicted. It's predicted using the regression line. So it will have a slope, which is denoted by b sub 1 multiplied by x, plus it will have b sub 0, which is the y-intercept. So b1 slope, b0 y-intercept. So this line, the equation of this green line that has the smallest possible error from all the possible lines that I could draw through these points, this is the one that has the smallest error. And this is the one that I will use to predict. So I want to go back to our data set with the height and the drill and so on and so forth. So I'm hoping that you saved it. So if I close, I don't want to close it here. I can just go back to my data set. Oh, I have it up here, actually. Okay. So for this data set, we found a correlation coefficient of 0.7728.
Is this the depth and time one?
Yes.
Or is this...
Yes,
Okay.
the depth and time. That's the only data set we entered.
I thought you said height.
I did say height, I think. Sorry, I didn't mean that.
You're fine.
My apologies. So now I would like us to go to regression. And it is simple linear regression. So go to stats, regression, simple linear. And let's click on that. Select the variable. X variable is depth. Y variable is time. And I would like to predict. Okay, let's say I want to predict something that I do not have here. So you see from 35 to 190, I don't have all the depth. Choose a depth that is not there.
135.
135 is good. So this is what I want to predict. I want to predict the y through the line for 135. So if x would be or were 135, what will be the time through the regression line? And this is a prediction. That doesn't mean that when I have a depth of 135 feet, that will be the time. And that it does not. But I have a prediction. I have something to think about. So let's compute. So here it is. Careful how we read this. So time is the y variable. Notice that this is Statcrunch gives us the answer twisted. It does not give us b1 times x plus b0. No, for some reason it's twisted. So it does not give us the slope plus times x plus the y-intercept. So I'm going to copy it down in the correct order. So I have y hat equals 0.01155301 times x, which is the depth, plus the y-intercept, which is 5.5272658. Also, it tells us very clearly here that the y-intercept is this b0, the slope is this. And now I want to determine for a predicted value, for a value that we do not have, we can also determine the predicted value for a value that we have as well. We can and we should. But I don't have 135, and I would like to see how long will it take through the regression line. And for x equals 135, I got that y hat, the predicted value is 7.0869 in minutes. Okay, now I also want to see this regression line and the cloud, which is the scatter plot, together. So that is the fitted line or the regression line. It graphed them both. And now I just realized that I did not show that with the calculator. So here it is. So if you go now to graph, aha! Only because I saved it already. If you remember, I saved the y in y1, the